Good morning. This is your Stats Sensei, Mr. Spensei, and this is a warm up on the paired t-test. So, scenario is we can't read. A 2 hour after school reading literacy course was advertised to raise. That's a key phrase. Raise indicates we're going to go up. Probably need to know that because that probably means we're looking at greater than. um, science test scores for seventh grade students. Administrators in a large school district with more than 2,000 seventh grade, that's going to be our population students to determine whether or not the program would be beneficial for their students. Um, the program is found to be successful in raising science test. If the program is found to be successful in raising science test scores, the school district would purchase the program and offer the after school reading literacy course to its seventh grade students. 8 seventh grade students were randomly selected. All right, so we have our sample size. N is 8. And administer a science test over the material that had been previously covered. After the students completed the reading literacy course, the students were then retested. Ooh, retested. That's an important phrase. That tells me they were tested twice. If they're tested twice, this makes it paired. So the fact that they were tested twice, that makes it paired. The pre-course and post pre-training program science scores are listed below. Also, the fact that it says we have pre and pre-course and post, all right, tells me that this is paired as well. So, what do they want us to do? Because we have all this data listed in the table. Using the data above, determine whether or not the reading literacy scores were effective in raising. All right, so this confirms what I said earlier. Raising is going to be the key. They're going to go, hey, we want to know whether or not literacy scores went up. So we're going to say we have pre, we have post, and we're looking for it to go up. We're looking for pre to be less. All right. And there's the order pre minus post training. So they gave us an alpha right here of 0.05, and they want us to run a t-test. All right. So this is a paired t-test. As I've said in my other videos, the paired formula is almost exactly the same as the regular, which is t equals x bar minus mu s divided by square root of n. The only thing is we're going to drop some d's on it because we're going to be looking for the differences because we're not looking for 80. We're looking for 80 minus 97, which is negative 17. So we care about the negative 17. So what I need to do is I need to go ahead and enter that data into the calculator. And there it is, the 80, the 97, etc. But really what I wanted the differences. So I'm going to go blue button 1 minus blue button 2. And there's my differences. They all appeared. Now I'm going to go stat calc, one variable statistics, and I don't care about the L1 and the L2, which is where this data is. What I care about is L3, so blue 3, because that's where my differences are. All right. So when I did that, I ended up getting a sample mean of negative 11.75. So on average, we think the post-literacy training scores are higher by about 11 points on average. So please don't forget, if we're working with a paired, when we're working with a paired, this will always be 0 for this class. All right. So we ended up with negative 11.75 points, standard deviation of 9.407 points, and we had a sample size of 8. Please remember that is 8 pairs. All right, this is 8 pairs. We actually input 16 things, but then we condensed it down to 8. So we know it's paired data, and we're going to run a one sample t-test, but we specifically need to include the word paired. All right, so make sure you include the word paired. One sample paired t-test. All right. All hypothesis tests are centered on the population mean. Please remember, confidence intervals are centered on the sample mean because you're estimating the population mean. But hypothesis tests are centered on the population mean. So our drawing is going to be centered on 0. All right. And we calculated here an X bar of negative 11.75. So this is negative 11.75. And we were saying that earlier we said that we expected to be less than post because, hey, maybe they made it 60 before and now they made it 80 because it went up. The post went up. So this is we're circling less than. We can go ahead and plug into our formula, and t equals negative 11.75 minus 0 divided by the sample size of 9.4074 divided by the number of pairs, or our sample size of 8. All right. Okay, our hypothesis. Well, our hypothesis is always simple. All hypothesis for entry stats is going to be an equal. So the null hypothesis is that it equals 0. All right. So in other words, there was no difference. If there's no difference, it wasn't effective. Okay. The alternative is that it's less than 0. Please note mu d, 0, 0. The only difference is this is less than. And we should also note this will always be equal to, and you've got to have the D's. All right. So let's go ahead and run the test. Now you can already see that I've already slid that up. So stat test t-test, because it's running just like a regular t-test. Our mean was 0. Our data list is an L3, so blue 3. We want less than, because that's what we said our alternative hypothesis was a less than. And we calculate, and we get a negative 3.5327 and a p-value of 0.0047. Well, we originally said our alpha was 0.05. Well, our p-value of 0.0047 is definitely less than 0.05. Make sure these are the same length. 1, 2, 3, 4, 1, 2, 3, 4. Add zeros to make them the same length because 47 is less than 500. So our decision right here is to reject the null. All right. Appreciate you watching. Look forward to seeing you on the next one. Thank you.